All right, guys. Good evening, all. Can you guys hear me?
Yes, sir. Hero.
Yeah.
Okay, okay, perfect. I yeah, I mean, I haven't formally introduced myself, but I think I'll do this at a later stage. But what I do recommend, get your pens, books, calculators out. We're gonna be solving integration. I'm gonna just warming up with these three problems, and then I'll be taking it further as we go along. That being said, if you don't understand anything at all, any particular step, um, yeah, please let me know. Also, we're gonna be working together, so I expect you to solve certain stuff as I move along. So I'm assuming that's how you typically do the session. I'm not sure. But yeah, anyway. So let's quickly begin. So I believe everyone understands what the concept of integration is. Is that correct? Heinrich, Lori, do you all understand the concept of integration? Okay. Um, okay, let me go the first example. And then yeah, and then if you don't understand something, you can just unmute your mic and tell me. So I do the first one, and I want us to gradually get harder. I believe it started with integration, and so therefore, but I see someone says they don't understand. So what integration is? It's many things, right? And one of them is, long story short, it's the reverse process of differentiation, right? Of dy dx or f of x prime. And I'm going to prove that to you. If you can just perhaps allow people to come in. I don't know if you guys can allow people to come in the lobby, but anyway. So let's quickly do the first one. I'm assuming you have some fundamentals over here. So we have 4x squared plus 7x minus 8. And obviously I'm just focusing on what's in the info textbook, but there's a lot I can say to this. But anyway, let's try to integrate this, right? So when you're integrating something like this, right? We have terms separated by a positive or negative, right? You want to apply the integration sign to each individual term over here. Okay, so let me just do that for you. So let me do it like this. What you're doing is you're timesing dx by each one, and then we're gonna have this over here. And again, if you're unsure of any particular step, you can just ask me. So once you have this, your next step is to apply the integration. Now, integration, just like a plus, negative, divide, raising to a power, it's just an operation which you're gonna write. It's an operation that you must do. So if you look at integration laws, um, I'm sure you guys looked over that. Are you guys familiar with it? Yes or no? You guys familiar with the integration?
Somewhat familiar.
Yes or no? I missed that.
Kind of, yes, sir.
Okay, great. Yeah, and talk to me, guys. So when you are integrating, right, there are set of laws. I'll explain to you exactly what's going on. So this is a case for just over here for anything with x to the power, right? And with a number in front or not even. So x to the power something. So when you integrate this one, you're applying this law, and it's quite simple. All you must do is, if you look at the law, you keep the constant, you add 1 to the actual power here, which is going to be 2 plus 1, and you're going to divide it by 2 plus 1, which is n plus 1, right? Just, I don't know if you guys can allow in the lobby. Okay, perfect. Just do that for me. You come over here as well, 7. The power is 1 over here, so that's going to be 1 plus 1, and that's going to be 1 plus 1. So you're basically dividing by the same thing here. So integration is like a negative 1. This is like a plus 1. And then over here, this could be looked at as 8 to the power 0, or 8 to the power x to the power 0. But and if you're going to do that, you notice that's going to be plus 1 over here, and then divided by 1. But typically for constant, if you can just know that all you have to do to integrate the constant, you just apply the variable next to it. And then we end off with this integration constant c. This is very important. This is the constant of integration. Okay, I'll explain to you this, hopefully, if you can get through that. So we basically do here is say 4x to the power 3 divided by 3 plus 7x squared plus over 2 minus 8x plus c. And that's your answer over here. So are you guys able to do this? You guys know about this? Let's make that bigger. Is this familiar to you guys?
Yes, sir.
Perfect. So let me, yes?
I can only speak for myself.
Okay. No, it's fine. I'm waiting for anyone who can just stop me.
Okay.
Let me just break this down further for you. I'm going to write this in a different form. And I'm going to show you now, how do you know that this is correct? So dy dx equals 4x squared plus 7x minus 8x. So when you're doing integration, what you actually do is say dy equals 4x squared plus 7x minus 8, and you're timesing dx over here. Okay? What you then actually do, you apply this integration, and then that's when you actually now integrate these steps into what we've got over here. But now, what you actually get after integrate, you actually will just get not a change in y, but a y. So what I'm trying to show you here, so this is actually y equals that. So for us to prove that we're correct, we must take the derivative of this over here, right? And if we get the correct if we do the derivative for differentiation correct, we should come exactly like that. So let me just quickly do this. Dy dx equals, so if you know your laws of integration, you're going to say 4 over 3, right? I don't know if you guys know this. That's going to be times 3, am I right? And then x 3 minus 1. Are you guys with me? You do the same thing over here. You're going to times by 2, and then you're going to say x 2 minus 1, which is basically going to be, I'll eliminate it like that. This up here, that's going to be 1 minus 1, and then our constant, we know it's going to be basically 0. So if you look at this, this will be 3 times that. You should end up with 4x squared. 2 times that, all of this, you should end up with 7x only. And 1 minus 1 is basically x to the power 0, which is 1, and it's that. So can you see that if you take this over here and you find the differentiation, you should get exactly the same answer over there. That's how you know you're correct. So no, understanding differentiation will help you a lot. Is that clear to everyone? Guys, have any questions, please ask, man. Yeah, it's going to be just easier that way. You guys follow? Katlego says yes, and I can't see all the teams. I can only see my OneNote. Heinrich, you fine. Sibulele, you fine. Lori, you fine. Taumari, you're right. Luvuyo, Obrey, Sipolile.
I'm good.
Okay, perfect. So I'm going to try number 3 again, and then I want you guys to do number 5. So let me just take out number 3 here. Okay, cool. So obviously, I'm assuming you have some experience over here. So yeah. So again, we've got 3 different terms. I'll just start integration immediately. So you're going to split them up. You're going to have 4 e to the x dx plus 7 cos x minus 6 sine x. Integrate that. Oh, and all of this, just forgive me, all of them have dx attached to it. Minus 6 sine x dx. So all we have to do is integrate this guy, and that guy. So here's a plus over here. So this one, what you want to actually first do before we integrate, we can actually just bring the e to the power minus x to the top there. Is that fine with everyone? Everyone comfortable with that mathematical process? Aubrey, yes.
Sorry, sir. Good evening, everyone.
Yes.
I'm busy writing down that first example.
Hmm.
Then can you write the last line down, please?
Yeah, so this is in the textbook, by the way, no? Just I'm letting you know. Yeah.
Thank you,
And
sir.
please don't please don't copy what I'm doing, I can write a
Thank you,
bit
sir.
messy. So make sure you understand. And at any point you don't understand, just please, you can just talk, because I can't see the teams. Aubrey, can we move on? Got the line there?
Just 1 second, sir.
Okay. So the key is understanding, not memorizing. It's fairly simple, in my opinion. Just gotta-
I would
Huh?
like you to explain for me, sir, that
Yes,
the-
yes.
that dx, that when you change over from integration to differentiation, that
Oh,
the
this part over here.
step. Yes, sir,
Yeah.
please.
So, like I said to you, integration is the reverse process of differentiation, right? So we're taking this function and we're integrating it into this over here. So what I'm saying is, to verify your answer over here, all we must do is take the derivative of this function or polynomial over here. Are you with me? So if you take the derivative, if you know your differentiation, it's going to be 4 over 3, times with the 3 minus 1. You know the power rule? Aubrey, are you familiar with that?
Yes, sir.
Yeah, so I'm doing the power rule on each term basically here. Do you see here? And in the end, you notice you'll get 4x squared plus 7x minus 8. So what I'm saying is, this is a form of checking, if you're right. So if you get the right derivative on this function over here, that means you're correct. Because remember, this is just essentially the reverse of that. You got me?
Yes, sir. Thank you very much, sir.
Okay. So yeah. So once you have this answer, if you find the derivative, it should look exactly like that over there on top. All right. So let's quickly do this. So I'm taking the 4 to the power ex to the top. And then I'll just write the same step again. So you don't have to write the same step again, but I'm just being very particular. So these integrations over here, if you do not know, I'll just pull it from a textbook. And each function will have an integration, an individual integration. So I'm just going to pull from the textbook so you can actually have a look. Give me a second. Just want to get the. So I'm working strictly from the textbook so you can exactly see where everything is. I'm just going to pull these ones here. So this is the first one. So those are your sine and cos ones. And of course, your linear function, or sorry, your exponential function will look like this. I'll pull up the other three as well. And I believe they are on your formula sheet. So if we integrate e to the power x, it should still be e to the power x. Okay. So always when you're dealing with constants, the way you must just view them like this. You keep the constant on the outside, you find the integral of the actual thing. That should have been dx, by the way. So that's 4 to the power ex, right? So similarly with this, if we integrate 7 cos x, right? So we just keep the 7 outside, we integrate the cos x. The integration of cos x will cos x dx. And I forgot this as well here. That's going to be 7 sine x. And over here, obviously we have I don't want to confuse you guys by this methods, but anyway. So here we have 6 sine x, and in fact, it's we're integrating the 6 sine x. So if we integrate 6 sine x, it should be negative cos. But when we have a negative here, and we're going to have a 6, and that's going to be, if we integrate sine, it's going to be negative cos, right? And in the end, we always add a plus c. So there is plus c's with each one, but we consolidate it with one big plus c at the end, which is a constant of integration. So then in the end, we have 4 to the power ex plus 7 sine x plus 6 cos x plus c. Okay. We all do that one. Am I helping you here? You guys can talk, please. I can't see. Makabongo says yes. Data says yes. Okay, Obi says yes. All right. So what I'm gonna do for the next one, I'm gonna set it up, and then I want you guys to integrate. I'll give you guys around, how many minutes should I give you? Maybe 3 minutes. Okay, here's number 5. Number 5 is over there. So this one seems complicated, but the first step when you have a lot of terms, you want to break them up. So I'll break them up for you. So 6 divided by, or negative 6x squared. Then you go minus 5. Now remember, 5x to the minus 1 is the same as saying 5 over x. So I'm not sure if you were told that the power rule doesn't apply where n is negative 1. And because the integration of 1 over x in this case over here will be ln x. I'm just making you aware. And I keep on forgetting this dx. So let me just do this again. So dx, I can say 5 times 1 over x dx. This over here, we have to split up individually. So this case will be plus 2 over cos x squared. Can you guys see that? Plus sine x over cos squared x. Okay, this could be slightly tricky. And this is all times dx. I should have put it all here. So and then for this one, when you integrate this one, you're gonna take this to the top, so negative 2, right? So can I quickly get the integral of the first two here before we move on? Can you guys quickly tell me? Nothing's tough. Just practice.
Is it minus 6?
This whole thing.
That's just the first part.
Okay, so if I'll do it's
No.
minus 6, yeah. So you're gonna add x plus 1.
Plus 1.
My bad. Sorry, minus 2 plus 1.
Minus 2
divided-
plus 1 is
And then obviously dividing by that, right?
dividing minus 2 plus 1.
Yeah, so this will be x what? Negative 1, am I right?
Oh,
Divided by negative 1. So therefore it's gonna be
6.
x minus 1.
6x minus 1. Yeah.
Yeah.
I got it wrong. So right now I saw my mistake.
Okay, perfect. Yeah. Guys, please respond in that way. And this one over here, so what's the integral of this one over here? So when you see 1 over x, you just got to think of that over there. So what is it? What's the integral of 1 over x?
Ln, right?
Yes, exactly. So we can just
X
say
ln
5.
1.
So we can say 5 ln x. You got me. You got it.
Yes, sir.
Yeah, perfect. So then over here, you want to simplify this, right? So I'm not sure if you guys have done tricks, and I see some people are unaware. Does anyone know what 1 over cos is, basically? You guys aware of the reciprocal ratios of these ones? You guys familiar with these ones?
1
You guys
over
know-
cos isn't it
Yes.
sec?
That is correct. Perfect. 1 over sine,
It's cosec.
100%. And then 1 over tan will be
Cot.
cotan, right? Cot, exactly. So in this case, we got a 2. If I could write it out here, maybe. So 2, 1 over cos squared. And obviously, this over here will now become sec squared. Okay, perfect. That's sec squared, x. This guy over here, if you look at him, I can remove that brackets over there as well. So this is going to be cos squared. Wouldn't that be like a 1 minus? Okay, sine over cos. Okay, so we have over here sine x. Let's make this big a bit. Yeah, we have sine x And then we
Over
have
sine
over-
squared x
co-
plus 1.
yeah, no, it's just we can do
Aren't
it
we
like
going to go
this.
that far?
No, we don't need to. I'll explain to you why. I'll explain to you why. That's fine.
Okay.
So we have basically this over here. Not cos x. It's 1 over cos x.
Mhm.
So this sine over x becomes tan x, and the 1 over cos becomes sec x. Right?
Okay.
That's fine. Now the reason why I did that, right? You might not know yet, depending on how much you've practiced. I'm just gonna put the integration table so you can actually see it. Because sec x tan x has an integral sign. So I'm going to just bring the whole thing up for you so you can see. And again, this is all from the textbook. So I'm going to paste that over here. So as you can see, each of these functions here has an integral sign. So that's the reason why I ended up with sec x tan x. And in fact, this should guide you because everything will somehow result into something like that. So what we have over here is plus 2. Okay, so let me just, I don't know why I can't remove this part here. Okay. So what we have over here, now we must integrate 2 sec x. So the integral of sec x, if we look at that, is tan x. So that will become 2 tan x. That's fine. Then over here, if I can remove this for you, just like this. This was tan x sec x, which in essence is basically this. Doesn't matter the order. And if you find the integral of tan x sec x, you'll get sec x, basically. And you just add a big c at the end. If you want to make this more cuter, you can just say that's over x over here. Over x. And that's basically it. Any questions on this one? Yes, pause and take 2 minutes, 3 minutes. Yeah, so just unmute your mic and talk to me. Talk to me, guys. Where are you lost? No one's saying anything. Sipolile, Siabuya, Liteta, Kateko, Sibulele, Lori, Yaomori. Any questions, guys, before we move on?
So can you just explain that last part where we
Okay.
had sine x over cos x times 1 over cos x?
Okay,
Because I'm lost there now.
that's perfect. So that's sine x. I'm just expanding upon this, right? Is that fine?
Yes.
So all I'm doing, I am separating the two. This is the same as if you maybe had, let's say I had 5 over 4, right? Then I'm saying 5 over 2 times 1 over 2. You know that this and that's the same thing. But it's 5
Yes.
times 1. Yeah, I'm doing exactly the same thing. Can you see I'm breaking it down?
Yeah, but the integration part, I'm lost there.
Okay, that's fine. So sine over cos is tan x, right? You got that.
Tan x, yes.
1 over cos is sec x. Got that as well.
Yes.
Okay, so what I'm saying, the reason why I ended up like that, because there is a standard integral for sec x, tan x. Are you with me?
Okay.
And so then if I integrate sec x tan x, it will result in sec x. Yeah, exactly. Are you with me?
I'm with you now, so.
Yeah, so if you actually apply the quotient rule over here, right? You know the quotient rule? Oh, sorry, not of this function. If you apply the product rule here, you know the product rule in differentiation? Remember that one? If you take the dy dx, then you keep the first function, you find the derivative of the second function, you'll come out to the same answer. Just by the way. Is there any other questions before I move on? You guys want to try on your own quickly?
Hi, can you just
Yes.
explain the previous step, the minus 6x minus 2?
This part over here. That one, it's just here.
Yes.
Sure, let's do it. Cool. So what I'm first doing over here, I'm just bringing them individually, right? Is that fine? I'm taking this guy, the bottom, and I'm bringing it to the top. You familiar with that, right?
Yes.
that.
Just sign.
Yes.
Perfect. So then I apply the power rule, which is this over here. You know, the one where we say x n plus 1 divided by, are you with me there? N plus 1. You
Yeah.
got that? Yeah. So I'm applying that there. So again, I'm just keeping the constant here. And then I'm saying x 2 minus 2 plus 1. And I'm dividing by the same, you know what I mean? The same thing here on top. Yeah. Why did I have a negative before? Oh, it is negative 6. So this is negative 6. Okay, fine. I forgot about that. So then we have negative 6 there, right? There's x to the power negative 2 plus 1. That's going to give you negative 1, right? You agree with me?
Mm-hmm.
Sure. Then negative 2 plus 1 is also negative 1, right? Got me?
Yes.
Yeah. So what's negative 6 divided by negative 1? That should give you
A
6.
6.
Positive.
Yeah, 6, right? Positive 6, right? And you left with 6 x to the power negative 1. Done.
Okay. Okay. Thank
You
you.
got me. And of course, we can take the negative 1 to the bottom like that. You know what I mean? It's a positive exponent.
Okay. Thank you.
Yeah, I appreciate the questions, guys. This is why I'm here. Okay. Are we good? Can we move on? Can I give you something to practice now quickly? Would you guys like that?
Yes, sir.
Perfect. So I'm gonna give you 2. You've got quite a few to go through. And guys, make sure when you leave my session, you understand. I'm telling you now, make sure. There's no question I can't answer. That's how confident I am. So make sure you make sure you ask me. I just want to find some questions here, some random ones, man. The polynomial ones. We must get back to these ones. I'm not sure what you're familiar with these ones. Okay, let's try this in the middle. Let's try 4.2. It's very busy. We can even try the one on top, but let's do 4.2. So I'm just gonna copy this one. I'm just gonna call this one in class practice. I'm gonna find one from the past paper. Okay. How long should I give you guys for this one?
3
How long do you
minutes?
guys like? Hey?
3 minutes?
Okay. Let's give it 4. Perfect.
Okay.
Yeah. I'll find another one so long while you guys are doing it. So once you guys are done with it, I will come in and I will solve, and then you can have questions again. Are you guys winning? How much time do you have left? Not in this book. All right, colleagues, can I come in? How much time is left? How far are you?
Can we have 2 minutes, please?
Okay, that's fine. That's fine.
Thanks.
I just want to say something because I don't see this book mentioning it here. And so that's 6 cos x. I don't like that it's not saying that though. Especially this part here. I don't think you guys are able to integrate this yet. This part here. Don't think you guys can integrate that yet. So yeah, I'm a bit. Even this over here, this could be a bit funny. Yeah, not yet anyway.
That's the ones I'm struggling with.
Yeah, ignore those ones for now. I'm realizing I took this one at the end of the book. I'm not sure what you guys know, what you guys don't know, but I'll show you now. No more. So just ignore those two for now. Then we'll come back to this one again and then solve that part. I'll explain to you. There's 1 more minute left. Oh, I'll come back to that one. All right, I think it's time, guys. Let's proceed. So these two we'll come back to after I teach you that other technique. Okay, let's assume the question just look like this. Okay, just like that, right? I'll add those two again, don't worry. So this one, take out the 5. In fact, let's just do it step by step. 7, this would be 1 over x, right? We know this integration sign in each one with the dx. I'm not going to put in the dx just for quickness. And we have cosec x cot dx. So dx is attached to all of them, by the way. Okay, anyway. Keep the 5, minus 3 plus 1, and then we're going to say minus 3 plus 1 over here. This one is going to be 7 ln x. We should know this by now, 1 over x, and we have minus cosec cot x. Let's quickly look here. You notice that cosec cot x itself has, and yeah, cosec cot x, right, will be minus cosec, by the way. Yeah, so it's minus cosec x plus c. So this would end up with 5x to the power negative 2, right, divided by negative 2. Minus 7 ln x minus cosec x. If you got these, well done. That's good enough. But you could
But-
also further, yes.
Sir,
Yeah.
there's a minus in front of that minus cosec.
Plus cosec. Thank you very much. That she's correct. Yeah. So it's let me just come in here quickly. It'll look like this. So let me just remove this over here. So it's minus cosec. Is it fine? Something like that.
Yes.
Perfect. And obviously you can make this a positive exponent as well. So you can say 5 over negative 2x squared. Oh, just like that. You can have it like this as well. Both of them are mathematically correct. Okay. Let me. Some of these stuff are necessarily long. Okay, that is one for practice. So let's look at some more examples over here. So where I am now, let me quickly show you. And then I'll come back to solving. So I'm just following the textbook over here. So I'm over here now. Okay. So I'm going to do a few of these ones here. But I recommend you can do any of these ones. Check the ones at the back. If you're unsure, I can explain these ones. So I'm going to choose a few of these ones, and then yeah, let's quickly see. Just to make sure I want to get to the substitution part, man, because I'm trying to do everything, yeah, as much as possible. But anyway, let's quickly go here. Integration to. Okay, let's quickly see. So I'm just gonna use this is what I want to do now. And number two is cool. Okay. I'll do number 2 first. So these ones are slightly more advanced. I think you gotta have some mathematical flair over here. Start with this one. Is there any possible way you think you can solve this one? Let me just leave it open first. What do you do first? Can I get some approaches?
Take out the
remove
square root.
Take out the square root.
Yes.
So you mean like this? How do we take out the square root? You mean like
Everything over.
that? Like that? Something like that?
Yes, something like that. Then it's
Yeah.
going to be 2x.
No, we cannot do that. Remember, the laws of exponents only works if they are multiplied to each other, not if they're separated by signs. Are you with me? So
Okay.
if it was like this, you understand what I mean? Then you can apply the half to each one. You got me? That's
Yes.
the Luguyo. Yeah. So you cannot do it like that. So that's not the right approach. Like I said, these ones, or it's slick ones, these ones are for the ones who don't drink beer on the weekends. So let's quickly see. So this one, what you're gonna do here, you wanna put this in. You wanna factorize this. That's the word I'm looking for, right? So if you factorize this with 2 brackets, and again, this is just coming with experience here. So it's 2x plus a 2, I believe, plus a 2. Just 2x times 2x will give you 4x squared. 2 times 2 will give you 4. If you add 4x plus a 4x, it'll give you 8x. So basically, you have two brackets or 2x squared plus 2 to the power 2. Are you guys happy with that?
Yes, sir.
Yeah. So can you see what the next step is now? This root will cancel that. That's square, am I right?
Yes, sir.
So it'll be power 2, but all of that is to the power of half. You know what I mean? So half times 2 is 1. You got me? Are you guys with me?
Yes.
Sir,
Yeah. So yes.
okay, I did try it. Why didn't you just solve it? Because it goes by a square root. You should. Is there a rule that said, other than on my understanding, I did factorize it. Then after then, I just made it in the simpler form as 2x. Then
So
from the
you did it like you factorize first, right? Is it fine like this?
yeah.
Sure. And then so what do you do with the root?
Then it
You
is
apply
the
the root.
same. I just then I applied took out the square root to simplify it further before.
So you do like
After that.
this. I'm assuming it's this, right?
Yes.
And then what's next?
Then no, I didn't do it like that. After then I made it 2x squared plus x all to the squared. Then I just took out the square root and then simplify it further.
No, but this is what I'm doing here. I'm just explaining step formulas. It's 2 to the power of half. So you're just canceling these two anyway. You see,
Okay. Oh,
it's just I'm just being very deliberate. So you're right. You see
okay.
that.
Okay.
So then we only
All
have
right.
that to integrate. Is it clear,
Yeah.
colleagues?
Yeah.
So let's integrate this together. What is the answer for this one? The first one and the second one. Obviously, we must split them up. What's the answer to this one? You're just plussing by 1. It's 2x plus 1, which is 2, right?
Yes.
Divided by 2.
Divided by 2.
If you have a constant, it's going to be 2x, right?
X plus C.
Yeah, plus c. And then we're done. So the ones who are unsure but why a constant is just with an x, I'll just articulate it again. Anything to the power of 0 is 1. So what you're not seeing, there's an x to the power of 0. Keep the 2, it's a x 0 plus 1 divided by 0 plus 1. And then in the end, you get 2x. Just by the way, if you're
Can we
unsure.
cancel the 2 over 2?
Exactly, you're supposed to do that. And then you end off with x squared.
X squared plus 2x plus C.
2x, exactly. Perfect. That's correct. Then you're done. Okay. Are you all happy with that one?
Yes, sir.
So this one you need a bit of flair. Let's see if you really have some flair now. Okay, number 3 is next. Yeah.
Yo.
Okay. What?
Oh, sorry.
No, you can talk. Be free, man. Is it because of my comment, huh?
My mic wasn't supposed to be on.
Nah, it's too late. We've got it. You might as well just continue with your. Okay. Does anyone know cos 2x identity? Quickly. I'm not sure if you're familiar with this. This is trigonometry now again. That's why you probably should have done tricks first. What is cos 2x equal to, colleagues? Does anyone know?
Isn't it sine squared to cos x squared?
Say that again.
Sine squared x plus cos
No.
x squared.
It's cos squared x minus sine squared x.
It's minus
is correct.
square. Other way
Yeah.
around.
Yeah, other way around with the negative, right? I'm just checking your formula sheet. Is it in your formula sheet, guys? I see it here.
No, I don't think so.
That's rough. Anyway, yeah, so it's not there. So it's cos squared x minus sine squared x. And we'll cover this in trigonometry. Okay, so what is next here? What is the next approach now? Are you all happy with that?
Yeah, I think now the following step you have to factorize the above one cos x squared
The
minus
numerator.
x squared.
And how do you
Yes.
do that?
You just gonna put you will do the same. It's gonna be cos x plus sine x close brackets cos x minus sine x.
Okay, so let me explain that. He's correct. He's talking about the difference between two squares, right? So you guys familiar with x squared minus 4? Have you guys seen this before? We asked you to factorize this. You open two brackets, right? It's going to be x, a negative 2, and a positive 2. Are you guys with me? The difference between two squares. Yeah.
Yes,
You guys got that?
yes, sir.
Perfect. So then we do exactly the same thing over here. So here on top we have, what is it again? A cos x minus sine x, right? Because you have a difference between two squares, as we can see there, and a cos x plus a sine x. And we just simply divide this out. Oops. Is that fine? Do you notice we have two common terms over here? Can you guys see it?
Yes, sir.
This one and the other one, right? And then we just left with cos x minus
Fine. X.
sine x dx, and then you integrate for me. So these ones, you got to do some manipulation first before you integrate. Can we get those answers quickly? I'm going to
Sine x plus cos x plus c.
There we go. Maybe someone is picking up, right? So it's plus cos x now.
Yes.
Plus c. Okay, that's, yeah, that'll be a negative cos plus cos. Perfect. Colleagues, any questions on this one? Any uncertainty? I'm hearing some mumbling there. Say, Matt, can you increase the blood pressure now? Just letting you know. Are we good?
We good, sir?
Okay, can I give you let's quickly see.
Number 5.
Number 5, right? Okay.
I can't speak for everyone.
No, for sure. If you first talking in the new year, you know, so number 5. I'm assuming it's the same number 5 we're talking about. Let's quickly see number 3 and number 5. This is the one, right? By the way, it's a square here. Eh? It's probably a typo here. Yeah, it's not a square. It's a 2. Okay. All right, can we proceed with this one?
Is that a 2x or sine 2x or sine squared x?
Sine squared.
Sine squared x, sorry. Yeah.
Oh, sine squared x.
Okay, yeah.
Okay.
So in this case, simple. If you have 7 minus 4 divided by 5, all you have to do is separate each term like this, right? That's what we're doing here. So we're just going to say 7 minus sine squared, right, minus cos x divided by sine squared x. That's perfectly fine, right? Dx. Okay. Obviously, if you're familiar with your trigonometry, 1 over sine will give you cosec. So this will be cosec squared. Are you with me? You guys comfortable with this? This on this side, let me just do it over here, is a cos x, right? Divided by sine x. Remember, I'm splitting it up just like the previous one. We know that cos over sine is called cot, and 1 over sine is called cosec. So we know that this is going to be cot x times cosec x dx. You guys got that?
Yes,
All
sir.
again. Huh? Sorry? No.
Yes.
Okay. All you must do now is integrate. That's it. And I'll be kind enough to put integration for you just here. There you go. By the way, I don't remember all this trigonometry stuff. I mean, yeah. So if you can see a cosec as an integral sign, which is cot, right? And cosec cot x, which is this over here as an integral sign, which is, again, which we've basically did before. Could you just get that answer?
-7 cot x plus cosec x plus c.
-7
Cot x
cot x, yes, I agree.
plus cosec x plus c.
Plus cosec. I agree with that. Colleagues, you all agree with that? Was it down Marie again, huh?
I'm gonna
sorry,
keep quiet
sir,
now.
to rewind.
Yeah. Siavuya? Yes, Chief?
Yes. Yes, I just want to know, how did we get cot x times cosec x?
Okay. So you see this, the cos x sin x squared here, right? You with me?
Yes. Yes.
I'm basically breaking this down over here. You see here?
Yes.
So I'm saying it's cos x over sin x times 1
Yes.
over sin x. You got me?
Oh, I see.
That's the flair you must have, you know, that's extra spice. I did it here as well.
Yes.
Um,
Okay.
Yeah, and guys, I appreciate the question. Where's the one I did now? Let me show. Like this one here. Remember this one here, sin x over cos x? Let me just make this big. You see this one here? Same story here. I separated the two.
Yes.
Yeah, I said here it's sin x divided by cos x times 1 over cos. You see what I mean? So what sin over cos is? Tan, 1 over cos is? Sec.
Sec.
Yeah.
Okay.
Sec. Okay, cool.
Okay.
The prescription is 2 hours a day, guys. That's a prescription for maths. Okay. Can we move on to the next section? Let's see. So let me just share the book with you again so you can see where we are. And then and guys, I appreciate the questions. Keep it coming. Someone said something? Having a stroke, sir? What's happening? Okay. Let me check the book. Where was I now? So guys, where we are now, do you guys cover this? Substitution. Yes or no? I'm not hearing nothing. Do you guys cover
Is it the
I haven't
part where
covered it
we
yet.
have the maximum and the minimum? Can I put it
No.
like that?
No. Not that.
Okay.
See, that's
What
here.
what page in the book is this?
Where was it now? 229, 230.
Oh, sorry, sir, where it involves the
Yes,
definite
yes.
integrals and indefinite integrals.
I'm not sure
Yes,
what
we
you're
have
asking me,
covered.
Chief. Oh, you have covered it, no?
Yes.
Okay.
When?
Okay, don't worry.
Of
Don't worry.
substitution in this guy's
called-
form.
It's called substitution. Yeah. Okay.
I think we
let's-
did.
Yeah. Okay. So let's quickly try a few. Is that fine?
Okay.
Yeah. So let me just do the basics here. Then we're gonna bring it up to speed. So these ones, yeah, this is when you become not necessarily a big chief yet. So let me just be careful with my words. Let me just quickly share again. Okay. So here we go. Integration. Sub. I believe I can share this note with you. Okay, let's quickly try this. So you'll notice it's normally easy to integrate when you have something like this, e to the power x dx, and you find it to be e to the power x plus c, or maybe if you have cos x dx and you integrate this, and then you're going to get sin x plus c, right? Now it comes in, what happens if this part, right, has a power like e to the power x? You know what I mean? Or sine 6x or 12x, just like the one we just did before. So I'm going to show you how you're going to actually deal with such problems. Okay, so let's quickly just erase these ones. Match is just a game, guys. You just got to know the rules. 4. So this one, e to the power 4x dx. So the amateur will say, oh no, let me just integrate, right? E to the power 4x plus c. No. But if you take the derivative of this function, the derivative of this is going to be dy dx. You integrate the inside part. I don't know if you guys know the chain rule 4. That's going to be e to the power 4x. That will stay the same. Yeah. And there will be a constant. But this and this is not the same. So therefore, obviously this is correct. I mean incorrect. So let me show you how you do it. So these ones, you got to always identify something called the argument. Basically, what's in the bracket. There's a bracket there, right? There's a bracket over there. There's a bracket over there. There's a bracket over there. Are you guys with me? You know what I mean there. So what you first do, you go into the inside function. So we call maybe this the inside function if you want. And you take the inside function as u. So u will be 4 to the power x. And once we do that, we have eu dx. Now the issue with this is that we have a u variable and we have a dx variable, and therefore we cannot integrate this. So now we need to somehow get a du here. And how do we find that du? So we find the derivative over here. So it's du dx equals 4, right? Am I correct? You guys with me? Is the derivative of 4x 4, right? I'm just teaching you the approach. Don't worry, we'll get used to it. So we're fine. So now, then we must put this in terms of dx, right? Because we want to replace this dx. So in that case, do some cross multiplication. You'll notice it'll be du over 4 equals dx. So we take this guy and we put it in here. So we have eu times du divided by, or we can say just say divided by 4. Now we take out, we split this even further. So it's eu times du times 1 over 4. You guys agree with me here? Can you guys see how I did that here?
Because you take the 4 up.
No, you can't take the 4 up. It's below. It's 1 over 4. It's a
You.
quarter. You know what I mean?
No.
0.25. Got me. So then remember, we just put the quarter there, e to the power u du, and we apply the normal integration. We keep the, and this is a simple integration because we have no power there, so it's gonna be a quarter eu plus c. However, remember that u was declared as 4x, and so therefore we must replace u with
4x.
4x. Now let me prove to you this correct. So if I take dy dx, I'm going to say, how does it go again? Yeah. Okay. I don't know if you know how to guys take the derivative of this. So it's going to be 1 over 4 integrate. Find the derivative of this. It's going to be 4x. Find the derivative of the inside function. It's going to be 4. The derivative of this is going to be 0. 4 times a quarter will give us e to the power 4x, and therefore we are right. So e to the power 4x. E to the power 4x. That means you're correct. So let me do another one for you. Okay? It's number 2. I hope you guys are following, right? So sine 9x dx. So what's my inside function over here? Can someone tell me?
Isn't 9x?
Exactly. So that means you take u as 9x. Next step, you say sine u dx. But we cannot integrate because we have a dx over there, right? So we define a du. So you say du equals du over dx equals 9. Do some cross multiplying, you notice that it will be du over 9 equals dx. Are you with me? You take dx and we take this one and you put it in here now. So it'll be sine u times du over 9, am I right?
Yes.
And I do exactly the same process. I can just say 1 over 9 if you slick sine u du. And we know the integral of sine u is what? Negative what? Cos, right? Am I right? Yeah. Negative cos, am I right? Negative cos u plus c, but obviously we just times 1 over 9 over here. So it'll be 1 over 9 over there. But you must remember we declared u as 9x.
U as 9x.
Yes, so it's 1 over 9 cos 9x plus c. Yeah, welcome. Welcome to Mathematics Info. You guys follow that? Any questions? Oh, what does that mean?
Okay.
It's not draft, man. Can I do another one?
Yes, please.
Okay, perfect. So this one is coming from example 6.10. Okay. Let me just quickly take that one out and then. So the key is defining u. So this is substitution, eh? So what is my u here? That's the first step. What is u?
Is it under the square root?
That's correct, yes. The inside, yeah. So what is it?
6x plus 4.
Exactly 6x plus 4. So you write that out, it'll be root u, right? dx. You guys happy with that? And obviously u to the power of, we can easily integrate, you see? So that's good, we're on the right track there. But remember, we want to replace that dx now. So we need to find the derivative of that function. So that's du over dx, and that will be equal to, what's the derivative of this over here? This is going to be 6, right?
6.
Exactly. And then we do exactly what we did earlier on, some cross multiplying, and we have du over 6 equals dx.
dx.
Perfect. We take this. Let me do it for you. Show you. See this one? We take that and we substitute it in place of that. So then we have root u times du over 6. But this obviously is the same as 1 over 6 root u times du. You guys got me? So then we follow the power rule or the polynomial rule of this. So it's 1 over 6. And we know that's u to the power of, am I right? So it's going to be u half plus 1 divided by half plus 1 plus c, but multiplied by that. Are we happy with that? Same rule. Plus 1, you know what I mean? And then divide by the n plus 1, which is the step bottom. Guys are going quiet there, eh? I don't like silence. I'm just using this. Can you see there? Then in the end, I have 1 over 6 times u to the power 3 over 2. Divide that by 3 over 2. Is it 3 over 2?
Yes.
Plus c.
Plus c.
Yeah. This, we can do the reciprocal, flip in times. So 1 over 6 times 2 over 3. And that's going to be u 3 over 2 plus c. And this should give you 1 times 2 is 2. 6 times 3 is 18. Which is obviously 1 over 9, I believe. And obviously, what was u again? U was
6x plus 4.
plus 4, exactly. So we just take 2 over 18, 6x plus 4. Is it 3 over 2? Sorry. I made a mistake here. 3 over 2. There's nothing wrong to make mistakes as long as you can fix them. That's what's important.
2 over 16. 6x plus 1 to the power.
Now, tell me we can
I
hear
am
you.
going to mute myself, so
Okay.
sorry.
That's all right. Okay. How's that one? Was the rough? So
Yo.
you guys. Yo. I thought you guys did this, man. It's not too bad, man. Nothing is rough. Just give me a second. I'm just reopening some stuff
That 2
here.
over 8, shouldn't we simplify it to 1 over 9?
Say that again.
That 2 over 18, shouldn't we simplify it to
Yes.
1 over 9?
Yeah, you can do that. Yes. Yes, that's correct. That is definitely correct. Yeah. Now I want you to try this one. And this is substitution as well. Okay, and then going back over here, can we see how we can easily do this now over here? Remember this over here? You guys remember this? We can easily do these ones now. Can you see there? We can easily do this now. But let me just do this one. Yeah. Okay, we're reaching my time now. Okay, cool. Yeah, try this one for me. So, anyone besides Dalmori, can you please tell me what your U is? What is your U?
2x plus 2.
100%. So I'll just leave it there. I'll give you guys 3 minutes for this one. Yeah. Take a shot. So you guys winning?
Done, sir.
Okay. So let me quickly do this one. Du dx. That'll be 2, is that correct? You guys agree with me, colleagues? Yes or no?
Yes, sir.
Perfect. Okay, I see some other thumbs up. Obviously, this will become du over 2 equals dx. We then replace this over here. That'll be du over 2. Like I said, we can just simply take out the half, u to the power 5, and then we have du. For those who feel uncomfortable with this, what this looks like is this. u to the power 5 over 1 times du over 1. That's what I'm doing. We keep the half. We're going to say u, we experience now, right? They look like that, plus c. That'll be 1 over 12, u6 plus c. But we know that u is equal to, what is it again? 2x plus 2. Beautiful. And we're done. All right, guys. I think we're at the end of the session here. So tomorrow, what time you guys normally meet tomorrow? On Saturdays? You guys,
8 o'clock.
8 o'clock. No way. Somebody probably was at 5 o'clock. That's why. I think 9 o'clock. 9 o'clock will be good. All right, that's a good time for me. And then I want to ask you guys, am I continuing with integration tomorrow, or what would you like tomorrow?
Is the trigonometry going to be in the test?
I'm not sure. I mean, I'm not responsible for
Yes.
the test setting. Is it there?
What did Sir say? Let me just double check.
No, Mr. Pico said the trigonometry is not gonna be there.
Okay. Just confirm, right?
Yes.
Because I just took the advice of the other student where they wanted revision or integrations. I thought I'll spend time. Obviously, I'm not even done with integration because there's a definite part and then the applications on the graphs, you know what I mean? So I like to do that tomorrow, but you guys can let me know. Are you guys good at differentiation?
We can continue because we only writing on 1, 2, 5, and 6.
Okay, so what is, let me just check quickly. But if there's anything, just tell me. I might-
We can do integration and some revisions.
Okay, but what revision on what? You must tell me so I can look for it.
Sorry, sir.
Yes.
I would like you to dwell here in that integration on where we are required to calculate an area on the graph to
Perfect.
the
okay.
script.
Yeah, that's fine. So see the test is what? 1, 2, and what? Just tell me again. 1, 2, 5, and 6.
Let me just double check.
Yeah. I'm just looking at the chapters here. Yeah, I know we're gonna do that
Good
tomorrow.
morning. Please note that trig will not form part of the test.
It's not part of the test. Right?
Modules is 1, 2, 5, and 6.
Okay, quite perfect. So we'll do definite integrals and then the areas under the graph because they feed into each other. That's
Yes.
fine. Differentiation, you guys are fine. Because you're not, you must talk to me now. No, talk to me. My info in 5 math levels, I'm still with surprisingly I can do that. I'm not rough. So please, I might explain it differently. I don't know. I don't know. Maybe I can go over chain rule. I don't know. I'm asking the house, but I for sure will go over definite and then the applications and the graphs, which can take a long time on its own.
How long is the class going to be, sir?
How long is the class normally? It's an hour, right? Supposed to be.
Hour. Yes.
Yeah. Maybe I
Okay.
can go over chain rule. I don't know. I'm not sure.
Yes, can we please do chain rule also?
Perfect. I know most students they battle this. Okay, guys, what I'm gonna try to do, I know it might be a bit longer, but I'm just doing it so I support you guys. We'll go over different integrals, probably do like 3 or 4 of them. And then the application of different integrals is areas under graphs. Okay. So just bear with me. Then I'll send the 2 recordings once I'm basically done. I'll send it probably on Sunday or maybe even Saturday evening, depending. But yeah, so and then after the application and the graphs, I'll do a bit of chain rule. Okay. See you guys tomorrow morning at 9 o'clock. No?
Thank
you guys
you,
want
sir.
you guys
Okay,
want
sir.
some homework? You want some homework? I
Yeah.
have something for you. 2 questions.
Yes,
Okay.
Okay, I'll put it in the group quickly. Maybe
Okay.
we can. Yeah, I'm gonna put it in now. Yeah. All from a past paper. There we go. Okay, guys. See you tomorrow at 9. Cheers. I hope you enjoyed it.
Yes,
Thank you, sir.
Yeah.
Okay, sir.
All right.
Thank you.
Booms.